Hi everyone, today we're going to investigate the speed of sound using resonance. Now we're going to need a few tools for this. First up, we're going to need an assortment of regular tubes. They should be straight-sided and as close to round as possible. So to do that, I've got an old grip from a bike, I've got some alfoil from the kitchen, an old torch, part of my vacuum cleaner, and of course my telescope. I need some way to close off the end of the pipe. Now for the first version of the experiment, I'm simply going to use this solid surface, place my tube on it, and call it done. The second version, I'd like to be able to adjust the length, so I'm going to use water in a bucket. I'm going to have my tube, I'm going to raise and lower it. I need some way to measure the length, so I've got a ruler and a small tape measure. And I need a way to make noise, so I'm going to use my phone, and I've got some headphones just to make things easier. Let's have a look at how we're going to do this experiment. You'll need an app that can generate tones. I use one called Function Generator, which not only does single tones, but can also sweep a range of frequencies. I'm going to start it at about 100 Hz and go to 450 Hz. I'll do this over the course of a minute, and I'll stop it when I hear the tube resonating or the volume being at a maximum. To make it easier to hear the change in volume, a headphone placed just inside the top of the tube can help. Once you've found the frequency where it's reasonably loud, switch Function Generator to single frequency and fine-tune it to find the loudest frequency. Now we have data for several tubes, we need to analyse them. The first thing we're going to do is enter the reciprocal of the frequency. We'll use Excel to do that, and then plot the length against that reciprocal of frequency. Add a trend line and set up the equation. You'll note in this case it's a very low value. Recall that the wavelength of the fundamental frequency of a closed pipe is 4 times the length of the pipe. Let's divide 4 by the value we just found from our graph to get the speed of sound. For the second version of the experiment, we're going to use a constant pitch and we're going to vary the length. Now, we already worked out previously that a 30 centimetre tube was going to give us a tone of around about 250 Hz. I'd like to use a shorter one. Let's put in 320 Hz into our frequency generator. What we're going to do is hold our tube, put the speaker in the top, and then put the whole assembly into the water. As we bring it up and down, we're varying the length because the water makes a closed surface. And we're going to lower that down until it's at the highest volume. Once we've found that length, we're simply going to measure the distance from the bottom to the top of the pipe. In this case, that's 22.5 centimetres. Now that we've found one relationship between the frequency and the length of the pipe, we can repeat that with a number of different pipes and see if the relationship is consistent.